Okay, good morning for contribute. So we are here, okay, to revise atoms, isotopes, and ions. So as I mentioned to those who had joined the Zoom meeting earlier, we will not just be revising content thoroughly and then doing some questions. On the other hand, we're going to be looking at the questions and revising the content along the way. All right. So what is the crucial thing in these June holiday Zoom consults is a few things. Number one, learning the skills, techniques to work on questions. When you see such a question, you need to apply such a problem-solving technique. The second important thing to learn is to actually revise some of these set 3 topics along the way, see what you have forgotten so that you can ask. So asking is crucial. Finally, and thirdly, is to go through some of the extension topics that you have already seen in the database questions so that we consolidate all these extension topics in your head. All right. Now, it is important to have extension topic knowledge so that at least you are not thrown off course just because something new pops up in your exam. All right. So it helps you build greater confidence over time. And that's the whole idea of the June Holidays Consult, is to build confidence and to give you an avenue to revise and ask. So if you are not asking me any questions in your free time, all right, it simply means that perhaps you are not revising in the right way. All right. Please don't feel bad that you have to ask questions. Everyone will have questions to ask. It's vital that you clear these doubts and ask them regularly. All right. So now we're going to start with atoms, isotopes, and ions. So I'm sure you already know by now, atoms are the basic building blocks of matter. Meaning atoms, they help to make up all types of chemicals that you see, be it carbon dioxide, sodium chloride, iron, metal. All these are made up of atoms in one way or another. And you already know by now that atoms, all right, they contain 3 types of subatomic particles: protons, electrons, and neutrons, right? So this you already know. So I don't think I need to go through that again. But what I perhaps want to go through is, if I go to the periodic table, I will immediately see sodium symbol. I will see the 2 numbers associated with sodium, right? The larger number is called the mass or the nucleon number, which I'm sure that you recall is the total number of protons and neutrons in the nucleus of the atom of the element. All right, so maybe I write it out in case you have forgotten. It's the total number of protons and neutrons in the nucleus of the atom of the element. All right, that's a larger number. So why is it called the mass number? It's called the mass number because obviously protons and neutrons make up most of the mass of an atom. Okay, so most of the mass of an atom is made up of protons and neutrons. It's due to the protons and neutrons. That's why it's called the mass number. All right. Now, the mass number is also called a nucleon number because protons and neutrons are found in the nucleus. Okay, finally, the last one is a smaller number, 11 in this case. That's the proton or atomic number of sodium. As the name suggests, the proton number is the number of protons in the nucleus of the atom of the element. Okay? So what's the purpose of telling you this? Because I'm sure you know by now, just based on these 2 numbers, I can work out loads of information. For example, I can work out that sodium has 11 protons. And because of this, I can work out that sodium has 11 electrons. Because atoms, the proton and electron are the same in number, because atoms are electrically neutral. Meaning, the number of positive protons equals to the number of negative electrons. Right? So there's no overall charge. That's why it's electrically neutral. Now, this was very crucial. This is how you distinguish between atoms and ions. Atoms have the same number of protons and electrons. All right, so you look at the proton and electron, same number, then it's an atom. Okay. And once you have this, I'm sure you can work out, okay, 11 protons, 11 electrons, it has 12 neutrons. How do we get 12? We take 23 minus 11. Okay, the mass number minus the proton number gives you the number of neutrons. I don't think this is very difficult. Okay, it's just a quick revision for us. And I've mentioned time and again, it's the electrons that we are interested in chemistry. I'm sure you've seen all the reactions you've seen so far. It's all about losing, gaining, or sharing electrons. Therefore, it's important to know how electrons are arranged. And I'm sure you remember this by heart. 2, 8, 1. 11 is 2, 8, 1, right? First shell 2, second shell 8. Finally, third shell 1 only. 2 plus 8 plus 1 is 11. Okay. Can? Now, this is the sodium atom. Right? Now, the sodium atom is obviously not stable. Okay, it will lose 1 valence electron to form sodium ion with a fully filled outermost electron shell. So what happens is it becomes 2A. All right, so this is sodium atom, this sodium ion. So how can you tell the difference between atoms and ions? Number one, ions have charge. In this case, the ion of sodium has a plus charge. More importantly, ions have two types, positive and negative. This is obviously a positive ion, right? Na+. So positive ions, they are formed by loss of electrons. Therefore, the electron is less than the proton because it's formed by loss of electrons, valence electrons to be specific. Okay, so this is crucial. This is crucial. Okay, positive ions are formed by loss of valence electrons. Therefore, the number of electrons should be less than the proton. Next, we have negative ions. Negative ions are the reverse. The electron is more than the proton. Why? Because it's formed by gain of valence electrons. Okay? Now, this is a key skill because very soon we're going to see a question that requires you to apply this. Okay, so this is how you distinguish between atoms and ions. Atom, P equals to E. Number of proton equals the number of electron, because atoms are electrically neutral. Ions are different. Ions do not have the same number of electrons and protons. All right, so ions is either positive or negative. Positive ion, electron is less than the proton. Negative ion, electron is more than the proton. Okay. Next, the electronic configuration of the atom also tells you a lot of things. It tells you that sodium is from group 1 because it has 1 valence electron. Right? 281, 1 electron in the outer shell. Therefore, it's group 1. Next, it also tells you it's from period 3. How do you know it's from period 3? Because it has 3 electron shells. It has 3 shells which are occupied with electrons. So this is how the electronic configuration is related to the position of the element in the periodic table. Position of element means the period and the group. Period is the number of shell. Group is the number of valence electrons. Okay, so this is just a quick summary and and really a recap of whatever you have learned since Sec 1 till now. All right. But what does the question look like? Now, the question sometimes you all feel is very tricky. When it's tricky, it's really because of the problem-solving technique, the analysis technique that you have for the question. All right. So if you just look at the one note now, the questions that I've put into JH1, question 1 and question 2, they are not really tricky, but very often, many of you do not get full marks for these questions. Why? Very often it's because the technique is not there. Okay. So once you have copied down the summary, I'll teach you how to do question 1. So hopefully you have the technique. All right. So once you're done, can you please give me a thumbs up so that I know you're done copying? And if you have any questions, please feel free to also ask either in the chat or by unmuting yourself. The rest of you all right? Okay, so I'll move on to question 1. Now, question 1 is actually not from Pure Chem, it's actually from the O-level Combined Science. But this is also applicable for Pure Chem because this is usually how we would set the first question of the Pure Chem exam, where we are just expecting a one word or one letter answer. But it's harder than it looks. It's harder than it looks because you are given numbers of protons in this case. You're given a number of electrons. You are given a nucleon number. So whenever you are given data, you need to pay attention to the numbers. In this case, you need to pay attention to what are the numbers in the first place. Like you need to know, right? For example, proton number is proton. Electron number is electron. Nucleon number, proton plus neutron. Okay, so it's important to know what the headers of a table means. Just like a graph, you need to know what the axis means. If not, you are not doing your best, right? To answer the question properly. Okay, so can we please take down this? Next, whenever you are given a table with number of protons, electrons, or neutrons, it is vital that you must first identify from the proton number what is the element. This is what is very lacking in like 99% of the class. Okay, I recall setting this for the end of year exam last year, and not all of you actually did this. Only 1 or 2 of you actually wrote out the element's name. So that's rather strange. The first step in doing such a question is to work out from the proton number what is the element. Take for example K, 2 proton. Proton number is 2. This is helium. L, proton number 5. That's boron. How do I know this? I go to the periodic table, I go to find. All right. So the first step is always go to the periodic table, use the proton number and identify the element. Bearing in mind the proton number is the smaller number. So smaller number 2, that's helium. Smaller number 5, that's boron. Immediately, once you do that, you are maximizing your chances of getting this correct. Because if you actually know what the element is, you probably can work out the reactions it will undergo, whether it's metal or non-metal, and so on. If you don't even write this out, I can almost guarantee out of 6 marks, you won't get 6. All right? Because you'll make careless mistakes here and there. Okay? Now, the next step is, whenever you are given such a data, proton, then after that is electron. You need to look at the electrons and determine, is it an atom or is it an ion? So we just went through just now, right? It's an atom if the number of proton and the number of electron is the same. P equals to E. It's an atom. So the first one is helium atom. The second one, L. L is a boron atom. M as well. Then you immediately see, oh, I got 2 boron atoms. The only difference, of course, is, okay, they have a different nucleon number, which is to say that the number of neutrons is probably different, right? That's why the isotopes are obviously L and M. This is how I can do it in 10 seconds. Because I know that I must identify the element. Once I identify the element, I will know which one is the isotope. Because these are two atoms of the same element. Same number of protons, but different numbers of neutrons. All right? So L and M are both boron atoms. They are isotopes of boron. They are atoms of the same element, boron. Then you move on to N. N is an atom. Nitrogen atom. O is a neon atom. P, sodium atom. Then the last one is Cl. But immediately you realize, okay, this is not the same. It has 18 electrons, 17 protons. So 18 electrons is more, right? More electron than proton. That means it gained electron, no? So this is a Cl minus, negative ion. So once you have this, you can quite easily work out all the answers that you need, right? Even without me saying, you probably can already work out A is L. Okay. Then B, placed in group 0 of the periodic table. It sounds like there's only one, right? And most students will just write neon, which is O in this case. But is that the only one? If you just wrote O, you don't get marks, you know. You can write both. Helium and neon are both in group 0. So it's K and O. So you can see if you didn't do the analysis that I did, definitely you will get this wrong. Next, 281, so simple, sodium, right? So that's atom P in this case. Will form an ionic compound with chlorine. Again, must be a metal, because this is a non-metal, chlorine. So you must choose a metal. So what's a metal? Sodium. And that's the only metal actually. Next is an ion with a single negative charge. Simple. If you have done the analysis, the answer is just Q. That's it. You must get 6 out of 6 if this comes out. There's no other way of doing this. You must go through the steps. First step, write down what is the element based on the proton number. Second step, based on the electrons, you compare with the electron and the proton, see whether they are equal. If they are equal, it's an atom. If they are not equal, it's an ion. All right. So 6 out of 6. Okay. So that's question 1. If you move on, you can see that question 2 is quite similar. It uses the exact same technique. All right. Okay, so I shall move on to question 2. So again, question 2 is again same technique, right? First step is proton. Look at the proton first. Tell me what is the element. 4 proton is beryllium. 8 is oxygen. All from periodic table. Don't need to memorize. It's from the periodic table. 19, potassium. You need to do this first, or else you'll get it wrong. Then the next step, electron. Is the proton and electron the same number? Is P equals to E? If P is equals to E, then the charge is 0. It's an atom. But immediately you realize, oh, for oxygen, that's not the case, right? It has 2 more electrons. 2 more electrons means it gained electrons. It gained 2 electrons. That's why it's O2 minus. Okay, next, K. Again, you can see, oh, the electron is not the same. It has 1 less electron. 1 less electron means it lost 1 electron. So the charge is not 0. It's an ion, right? It's K plus. Now, we haven't finished. You still need to write the nucleon number in. So that's following the example in the first row. We need to write nicely like this. And that's it. Right? So again, such a question, when it comes out, it uses the exact same problem-solving technique. So you should not get it confused. Okay. So using the data in the table, explain how you can tell whether an atom, a particle is an atom, positive ion, or negative ion. This one we have already gone through. Is by comparing the number of protons and electrons. Okay, if you are still unsure, please ask later on. So that's question 2. Now, question 3 applies the same problem-solving technique. Okay, so question 3, I strongly advise you to try it on your own so that at least you practice this problem-solving technique. Now, many of you, your papers, when you hand in to me, the question is not annotated, You have no working whatsoever. And it's because you don't have any working whatsoever that you make careless mistakes. Now, many of you do say that you make a lot of careless mistakes, but are these really careless mistakes? Or do you consciously not think through the question? It's very convenient to say, oh, I was careless. Oh, I didn't see this. But why? Why do you not see it? Is it because you don't have a habit of annotating and thinking through like this? If you don't have this habit, you must develop it, all right? It's important to be meticulous when you read through something. So that's question 2. It's done already, right? So if I may move on, please give me a thumbs up so that I can move on. Okay. Now, so far we have gone through basically questions involving atoms and ions, all right? So you can see question 3 again applies this technique, all right? The moment you know it's a cation of a 2+ charge, it has 26 electrons, means what? 26 electrons is after it has changed the electrons, right? 2+ means you lost 2 electrons. Meaning originally, it must have had 28 electrons. If it has 28 electrons, it has 28 protons. Right? Originally, it must have 28 electrons. That's why you lose 2 electrons, becomes 26. And with that, you can easily work out if it's 28 protons, the mass number is 60. So the number of neutrons is 60 minus 28, which is 32. So answer is D. Okay, so this is a typical MCQ. So you must go through the thought process. The thought process starts here. This is the first thing you need to learn. 2+ charge means lost 2 electron. Means originally I got 26 plus 2. Okay, 28. At first it's 28. You lose 2, then become 26. Okay. So it has 28 electrons originally in the atom. Then, if it has 28 electrons, this allows you to work out the number of protons. It's 28. Right? Finally, to find the answer, number of neutrons, we take the mass number minus the proton number. Okay, 60 minus 28 gives you 32. So the atom has 32 neutrons. The cation also has 32 neutrons. Because remember, to form ions, you only lose and gain electrons. You do not change the proton. You do not change the neutron. Okay. All right. So now we have the next one, question 4. Okay. This one is relatively challenging because you have seen the graphs, right? P, Q, R, S, T, right? And it asks you which statement is or are correct. The way to do this kind of MCQ is to read through every single statement. Okay, in this case, 1, 2, 3, 4. Read through and think through every statement. That's why annotation is important. If you don't annotate, most likely you're going to get it wrong. Okay, So now let's go through question 4. Annotate with me. Or look at what I'm annotating. Statement 1, Q represents an electron. So you got to think, what is electron? Electron, the charge, the relative charge is -1. The relative mass is 1/1840 or 1/1836, right? So if you look, Q, the mass is like very small, close to 0, not 0, but close to 0. So the mass makes sense. The charge also makes sense, right? That means statement 1 is correct. Next, we have R. R represents a H plus hydrogen ion. Hydrogen ion is H plus. You have learned this under acids. Acids produce hydrogen ions, H plus. All right, not H minus. H minus is not called hydrogen ion. H minus is called hydride. Hydrogen ion, we mean H plus. H plus, obviously the charge is 1 plus. Right? So in this case, R looks correct, right? It's +1. The mass should be 1. Hydrogen is 1. Oh, looks correct too. So statement 2 is correct. Once you have this, isn't the answer obviously C? Yes? Now, but let's go through further. Why is statement 3 wrong? T represents the nucleus of helium atom. Nucleus, the key word here is nucleus. This means that it should be no electrons in the nucleus. We already know nucleus don't have electron. They want you to talk about the nucleus, not the atom, but the nucleus of the atom. So the nucleus only got proton and neutron. So if you look at helium, this is from the periodic table. Helium from the periodic table has how many proton? 2, because the proton number is 2. How many neutron? 4 minus 2, 2. So this tells you that, okay, helium, the nucleus has 2 protons, 2 neutrons. Protons are positively charged, meaning the nucleus should be positive. Specifically 2 plus, because it has 2 protons. So if you look, T has 0 charge, so it's wrong. So T is not the nucleus. Okay? So T is not the nucleus. T is actually the atom itself, not the nucleus of the atom. Okay, and finally, S and T, they are nuclei of isotopes. Because they are nuclei, that's why they have a charge. Okay? Can? So you can see, you're going to read the statement thoroughly. If just one part of the statement is wrong, then the whole statement is wrong. To be correct, the whole statement from the start to the end, every word must be correct. Right? Okay? So this is a typical kind of MCQ, paper 1 MCQ that you should expect to see, be it for prelims, for O-levels. Okay, even your workbook, you will have seen some of these. Okay, and that's why it's important to practice the MCQ revision set that I've given, because there are many questions like this. So by now, if you have finished the MCQ revision set, you should have this mindset that when you see such questions asking you to evaluate whether the statement is correct or not, you need to read through every one of these statements and make sure that every single word is correct. If every single word is correct, then it's correct. But if just one part of the statement is wrong, the statement is wrong already. Like statement 3. Okay. Okay, now moving on to the next part. Now, this is the part that I think many of you are very confused. Okay, I'm sure you remember how ions are formed. You remember that ionic compounds exist as a giant ionic lattice. Okay, these three words: giant, ionic, lattice, right? So what do these three words actually mean? Okay, start with the ionic. Ionic is easy lah. Huh? Ionic means made up of ions. Ions are the particles, not atoms, not electrons, it's ions. Okay, next, lattice. Lattice is a regular, repeated, three-dimensional structure. So the ions are arranged in a regular manner that is repeated throughout the whole solid. That's a lattice. Finally, giant. What does giant mean? Giant means the ions go on and on until the boundary of the solid. So if you have a crystal of sodium chloride, the ions will be arranged on and on and on and on until they reach the boundary of the sodium chloride crystal. Okay, and that's important. This means that sodium chloride is not just one Na plus, one Cl minus. Or NaCl is not one Na plus and one Cl minus. It's not. Because just one of each ion wouldn't go on and on. The idea is go on and on, you know. So how does it go on and still be NaCl? NaCl is made up of Na plus and Cl minus ions in a 1:1 ratio. This is the correct way to phrase it. It's about the mole ratio between the ions. It's not about how many ions. NaCl is not one Na plus, one Cl minus. It's about what's the ratio between Na plus and Cl minus. Okay, so this crystal structure that I've given you, you can tell that it fits NaCl. Why? How can you tell that it fits NaCl? The key thing is to count. You have to count the number of each ion, then you work out the ratio of the ions. That's the key. So if you count the ions, you will come to the conclusion that you have 13 green, and the blue, if I'm not wrong, will be 14 blue. Right? Yep. Based on the diagram, you have 13 green, 14 blue ions. Then you'll be like, oh, but 13:14 is not 1:1. It's approximately 1:1. Now, why is it that you have missing ions? You have missing ions because if you just look at the structure, is this the whole crystal already? Can we ever show you the whole crystal? The whole crystal is made of millions and billions of ions. This is just part of the crystal. When you have part of the crystal, there will be parts that are missing. That's why that one ion missing is actually somewhere else in the crystal. All right, you are only shown part of the crystal. So in this small part of the crystal, you can already tell that it's roughly 1:1. All right, therefore this is NaCl. This is also the structure of other things like MgO. Basically, everything that is in a 1:1 ratio will fit this crystal structure. It cannot be something that is not 1:1. For example, it cannot be calcium chloride. CaCl2 cannot. Okay, so the idea is to count the number of each ion from the picture that you are given, then work out the ratio, and what is the ratio closest to in integer values. So 13:14 is closest to 1:1. All right, not 1:2 definitely, right? Now, there's another good way of doing this, which requires more visualization. But the visualization method is actually the correct way. So you focus on one of the ions. Usually, I like to start from the ion in the center. So you can see the green ion. The green ion in the center, which I've just highlighted, is bonding to a total of 6. 1, 2, 3, 4, 5, 6. The green ion is bonded to 6 ions, 6 other ions, right? Now we can do the same for the blue ion as well. Now this one will be a bit difficult because I've already highlighted for you to see, right? So I need to remove some of the highlights so that at least it's clearer. So if we look at this blue ion is bonded to 1, 2, 3, 4, 5, and one more below, 6. Again, like I said, there are certain things that are not shown. You're only shown part of the crystal. So you got to imagine it's a regular repeated structure. So what would it look like? There's one ion at the bottom. So we can see that each ion interacts. So we can say that each blue ion interacts with 6 green ions. Similarly, each green ion interacts with 6 blue ions. Isn't this 1:1? 6:6, right? 1:1. Okay, so this is the visualization method, which is a bit more complicated because you will need to visualize, especially ions that are not shown in the picture. You will need to visualize how does this structure repeat on and on. Okay, but it works. It's actually the correct way to do it. Okay, now this is simple. This is the 1:1 kind of ionic lattice. All right. So if you're okay with this, you have copied it down, please give me a thumbs up, then I'll go to the next one. So you choose either method, either you count, then you work out the closest ratio. Okay, that's one way to do it. Otherwise, you have to do the visualization method and count. Each ion interacts with how many other ions. Okay. All right, moving on, part B. This is another ionic compound, obviously. It's another ionic compound. And this ionic compound confirm is not 1:1. Confirm is not. It's like so different, right? It's so different from A. So what is this? So again, you count how many blue. So you count. Okay, oh, so it's 14 blue ions. How many green? 8 green. So immediately, oh my God, it's not 1:1. Clearly, it's 2:1. So what is 2:1? A few things. MgCl2, 2 chloride, 1 magnesium. 2 fluoride, 1 calcium. Could also be 2 sodium, 1 oxide. Okay, and so on and so forth. Basically, things that are not 1:1. All right. Now, we don't know whether the green is positive or negative, so it can be any one of these options. So usually this appears in MCQ. You will need to deduce, oh, so it must be like this kind of ratio. That's why the formula is like that. Now, you're not expected to memorize any of this. We will give the diagram to you and ask you, what is the likely formula of the compound? Okay, so if you are lost, you can go back to my Sec 3 semester 1 revision set. It has some questions like that. Okay, I just thought to go through it now in case you didn't know how to do it or you have not done my revision set from Sec 3 semester 1, the MCQ. You will realize that many schools set this up for their prelims. So you need to be familiar with how you deduce what is a likely formula for the ionic compound. Okay. Are we doing all right on this? Okay. All right, so these are the two possibilities, the two main possibilities. Now, these are not the only possibilities, okay? Don't get me wrong. Okay, studying crystal structures of ionic compounds is a whole university module on its own. All right, so this is just an introduction for you to see what is the likely formula. We are not testing whether you have memorized the structure. We are only testing whether you can deduce what is the likely formula from the structure given to you. That's a skill. All right. Now, moving on, we have the last section of today, which we are doing good on time. All right. I don't intend to take the full duration because I know it's tiring to listen to me drone on and on and on. Okay. But the last part is very commonly tested for your pure chem questions. You would have seen this word ionization energy so many times, right, in your database questions. But yet, it is not in your textbook. Okay, so this is one of those novel new contexts that many schools would love to set. So you need to know what's ionization energy. Now, specifically, there's first ionization energy, second ionization energy, and so on. So let's go through what's first ionization energy. First ionization energy, first IE for short, is the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms to form 1 mole of singly positive gaseous ions. Okay, this is a full definition. It's given to you in the question. So if you have done the database questions, you would have seen this so many times, right? We have typed the whole definition out. And if the definition is given to you in database, you must highlight it. Remember, I went through during database. One of the main things to look out for in database is definitions, trends, and patterns. All right, so this is the definition. So if it's sodium, the first IE is the energy required for this process. Is the energy required to remove 1 mole of electrons from 1 mole of gaseous sodium atoms to form 1 mole of Na+. Similarly, if it was, let's say, phosphorus, let's say, then it's like that. Okay? So this is the first IE. So now if you look at the first IE across a period, so I've given periods 2 and 3. Okay? Actually, period 1 also there. Hydrogen, helium are also there. So there's period 1. So period 1 is here. Then period 2, these are in period 2 in yellow. Then you have period 3 in blue. Right? Immediately you see a few things. Right? First, is it true that first IE always increases across a period? Does first IE always increase consistently? You just look at the graph, right, across a period. Let's say you just look at period 2, for example, all the yellow color ones, period 2. The first IE doesn't always increase, right? It's not like it's always going up. If it's always going up, it's just a straight line up. But it's not. It zigzag at certain points. So this tells you that first IE does not increase consistently. Because there are exceptions, right? For example, there's an exception at boron, there's an exception at oxygen, for example. Okay, so because there are exceptions, it is not true that first IE increases across a period. However, you need to add one word to make this statement correct, what is that one crucial word that we went through during database? It is not correct to say it increases, but it's correct to say it increases generally. So there's a difference. You might have learned this in geog as well. There's a difference between general and not general. General means there can be a few exceptions here and there, but generally it increases. Okay? Now, this one you have not learned, but what if you are asked to explain? Hey, explain why first IE generally increases. So you got to think, what is first IE? First IE is the energy required to remove electron. Why do you even need energy to remove an electron? In an atom, the electron is inside the shell, right? So why will the energy be required to take the electron out? Energy is required because the electron, it is attracted to the nucleus, right? That's how the electron stays there, right? The electrons are attracted to the nucleus. Why? Because the nucleus is positively charged. It has protons. So you need energy to overcome the force of attraction between the electrons in the shell and the protons in the nucleus. So energy is required to overcome the forces of attraction between the electrons and the protons. The protons are in the nucleus, the electrons are in the shells. Okay. So why will the first IE become higher? Higher means you require more energy, harder to take electron out. Why do you think it's harder to take out, pull out the electron? It's harder to pull the electron out if it is strongly attracted to the nucleus. And that's the idea. The first IE increases generally because across a period, proton number increases. Proton number increases across a period. That's obvious. When you go from left to right, sodium to argon, the proton number increase. Got more and more proton. If there are more and more protons inside the nucleus itself, the electrons are more strongly attracted to the nucleus. Right? If they are more strongly attracted to the nucleus, then it requires more energy to be removed. Okay? So that's the first thing that you notice. The second thing that you'd always notice is that the maximum, the peaks in the IE always occur with these elements: helium, neon, argon. So what do helium, neon, and argon have in common with each other? There must be some similarity between helium, neon, and argon. If not, they won't demonstrate this maximum IE, right? So what is the similarity between these three elements? They are all in group 0. And group 0, they are all known as noble gases. So you notice, noble gases, which is group 0, have the highest IE. Always. Why? Why might that be the case? Why do you think it requires so much energy in order for the noble gases to lose electrons? Because we already know group 0, they have fully filled outermost electron shell. Helium, outermost shell filled fully. Neon, also the same, fully filled. Argon, also fully filled. That's why they're all in group 0, right? So what if you have fully filled outermost electron shell? What's the implication, the consequence of that? It means that it is very stable, right? We have learned that noble gases are very stable and do not lose, gain, or share valence electrons. That's why it doesn't want to lose electrons, because it's already very stable. Doesn't want to lose, doesn't want to share, doesn't want to gain. Okay. Now, I know this is quite advanced. Okay, you might think that, well, it's quite complicated, but it's something that is can be reasoned out if you have good concept of what it means for electrons to be in a shell attracted to the nucleus. Okay. So I've gone through two different things. The first thing I've gone through is, why does first IE increase generally across a period? The second thing I've gone through is, why do noble gases have the highest first IE in their entire period? Okay. Now, moving on to the next part, the next table, if you like, is where we look at a table of the first ionization energy and the second ionization energy. All right. So if I can move on to the next part, can you give me a thumbs up so that I know that you're done with the copying, and if you have no questions. Okay, so moving on. Now, the next part is actually the second last part already. All right, first versus second IE. So what is first IE? So revise. First IE, for example, sodium. Sodium lose 1 electron. Then what is second IE? Second IE of sodium means I lose a second electron, right? Then you're like, oh my God, why will sodium want to lose another electron? Doesn't sodium just lose 1 electron? Well, I think the numbers will show that, right? Do you realize that sodium doesn't want to lose a second electron? Why? Why is the second IE so much higher than the first for the group 1 elements? Second IE is much higher than first IE for lithium. Lithium is like sodium is in group 1, right? So why is the second one so much higher, 7,300, no, as compared to say 500 for the first IE? Why? This is because the second IE involves Li plus losing 1 more electron. Li plus does not want to lose another electron. Why? Because Li plus already has fully filled outermost electron shell. We already know, right? Second IE means you start with the ion, no? You start with the positive ion and try to remove 1 more electron. Li plus, just like Na plus, wouldn't want to lose a second electron because Li plus already has a fully filled outermost electron shell. Okay? And this is how we actually deduce that lithium has only one valence electron. Because to remove the second electron is so much harder. It's so much harder to remove the second electron, which is from the inner shell. It's no longer from the outer shell, it's from the inner shell already. That's how we know that lithium has one valence electron. There's only one electron in the outer shell. So after you remove the outer one, the second one comes from the inside, which is very hard to remove. Very hard. So much harder to remove. All right. And with that, actually, this is quite a useful rule, right? We just have to look for where is the huge increase. For the case of lithium, the huge increase occurs from the first to the second IE. That means removing the first electron, okay, not so bad. But second electron, wow, super difficult to remove. This means the second electron is inside, not outside anymore. So if I have another element, how do I determine the group? I look for the huge jump. I look for the huge jump. This is the third electron. This is the fourth electron, right? 1, 2, 3, third to the fourth. From the third electron to the fourth electron, there's a huge increase in the ionization energy. What this means is to remove the third electron, still not so difficult. But the fourth electron, very difficult to remove. This means that the fourth electron is from the inner shell, whereas the third electron is still in the valence outer shell. So with that, I think it's quite easy to predict how many valence electrons do you think this particular element will have. So this particular element has 3 valence electrons. If you have 3 valence electrons, means group number 3. Okay, so this graph is actually for aluminium. Aluminium is from group 3, and you can clearly see that the third electron to the fourth electron. The fourth electron requires a lot more energy in order to remove it compared to the third. This means that in the outer shell, there's only 3 electrons. Hence, 3 valence electrons, group 3. Okay, now I want to go through this content, not so much for you to memorize, but to have you have the concept of ionization energy as the energy required to lose an electron. Okay, why do you need energy to lose electrons? It's because they are actually attracted to the nucleus, specifically the protons. So you need energy to overcome this attraction. Okay, and from ionization energy, we can branch out to many patterns. As we have seen, some of the patterns include noble gases have very high ionization energy. From left to right across a period, ionization energy generally increases. Finally, just by looking at the successive consecutive electrons removed, we can clearly work out which group is this element from. Okay? So these are different things that could be tested as a novel context to see how you actually apply the concept of ionization energy to working different things out. Okay, so you have seen some of this in your database. I hope this serves as a consolidation for you. After doing the database, what are the possible types of questions that can come from such a concept of ionization energy? So today we have gone through a fair bit, all right? We started off with atomic structure. We started off by talking about numbers of protons, electrons, and neutrons, something simple, but we quickly went on to apply this using a problem-solving technique. you need to work out the name of the element from the number of protons. All right, that is question 1. Number of protons gives you the name of the element. Then you look at number of electrons. That tells you whether it's an atom, positive ion, or negative ion. Important problem solving technique. All right. So I should see all of us must have annotated. If question 1 comes out, everything must be annotated like I have done. It should not be blank. If it's blank, very likely you will not get 6 out of 6, which is a waste because it's actually quite straightforward once you have annotated. Okay. Then we also went on quickly to talk about how do you deduce the formula of an ionic compound given the crystal structure, which is here. All right. We will give it to you. Don't memorize it. We will give it to you. What you need to learn is the problem solving technique. The problem solving technique is to count the number of each ion and work out the integer ratio of the ions. Okay. So like NaCl, MgO, so on. Okay. Finally, we went through the concept of ionization energy, which you have seen a number of times. So I hope this consolidates your knowledge of ionization energy. Okay. Now, don't go and memorize. Like I said, pure chem, only 15 marks is memory work, no? Out of like so many marks, 15%, sorry, only 15% is actually recall. The rest is all about understanding and applying. Applying takes up 55% of your marks. So if you want to do well, you must have the concept, understand it, and apply it. And that's why I keep on saying you have to ask. When you ask, you are learning how to apply. When you annotate, you are learning how to apply. If you don't annotate and break down a question, you are not applying anything. All right. And if you just rely on closing the book and memorizing and chanting, that's not going to help you in the longer run. All right. Can? So after you have copied down all this, you are bound to have questions. And that's why you have to ask the questions, either via WhatsApp or you find me separately to a Zoom. We go through the concept and you ask the question and I answer you on the spot. That's how you can improve. Okay. There's no simple formula to improving in the subject or in any subject. You need to learn how to apply your knowledge. All right. Now, this is the end of today's lesson. The next lesson, which is on Thursday, we will continue with, if I'm not wrong, was giant covalent structure, right? Yep, covalent bonding and giant covalent. All right, so that's where we will revise some of the things that we did last year. So like diamond, graphite, carbon nanotubes. So these are examples of things that we will revise. All right, so hopefully this revision also gives you a start to do some of the papers that have been assigned to you, because the idea is we should reduce our homework backlog from the June holidays. Use the holidays to finish whatever homework that you did not manage to finish. For example, the MCQ sets given out in Sec 3, if you have still not finished them, it's time to make a start and do as much as you can before the term begins again. All right? These will give you practice on how to break down a question, how to handle different sorts of different contexts in questions. Okay, so that brings me to the end of today's lesson. I shall see you on Thursday at the same time to go through giant covalent structures. All right, so I shall end the lesson and the recording here. Thank you.